In this video, we're going to be continuing our lesson of 11.3, talking about measures of variation still, but with a new piece of information. We are going to just do one little review, reminding you about the differences between what we've learned so far, measures of center versus measures of variation. This is the lesson we're continuing with for tomorrow as well. Remember, measures of center, mean, median, mode, summarizes a set of data with a single number. It's different than what we're talking about with measures of variation. Range, measures of variation include range, IQR, which does involve the median and the Q1 and Q3, but it uses a single number to describe how the values vary, or how the spread is, how far apart are the numbers. So, in this video, we're basically going to focus on outliers. And I have a couple of pictures to help you with this word, kind of wrap your mind around it. When I think of outliers, I think of outlaws. They're kind of like the troublemakers. They maybe don't make all the right choices. The word liar is in outliers. It's also not a very positive thing, like Pinocchio, he lied all the time, that wasn't good. So outliers in general can make things messy and kind of cause some trouble when you're looking at data. You have to be careful if your data set has any outliers. So I'm going to show you what outliers look like. To get ready for this lesson, you're going to want to have this yellow sheet of paper. This is going to get glued in to page 72. We're going to be doing an example on page 73. So if you want, make sure your table of contents looks like this. It has page 71 and 72 just labeled with outliers. And you can glue this in to page 72. So here is the beginning of those yellow pages of notes. What is an outlier? An outlier is a data value that is either extremely big or extremely large, extremely larger, or extremely smaller than the other values in the data set. So we are talking about the extreme ends of your data set. Write that in your yellow sheet. Here's an example. It's a little blurry, sorry. I made it bigger thinking that would be better. But you can see that there's a line plot. You have the number line here with x's above 2, 3, and 4. This is where most of the data is. We call this a cluster. Then there's this big open space. There's this gap here. And then there's one little number over here. That will be our outlier. It's our odd guy out, as I like to say it. Everybody else is clustered over here, and then there's one way out in left field. So that's one example of what an outlier could look like in a graph. Here's another one where most of the numbers seem to cluster on this line, but then we got this odd guy, and that's an outlier as well. He is much higher than the other data points. Here, in this dot kind of demonstration, we have the cluster here, and then these two are not in that same general pattern. Those are also outliers. And there is a requirement for whether a data point is an whether it is an outlier or whether it is not. And that is that it must be 1.5 times the value of the IQR range beyond the quartiles. Now, that might not make sense to you right away. That's why I kind of have these down here. Well, what did I just say? Well, I'm going to show you what I mean. It's got to be far enough away. And what is that boundary? That's what we're going to have to find, so that anything inside that boundary is not an outlier, but anything outside of the boundary is an outlier. And that fence, so to speak, has to be 1.5 times the IQR range, or the IQR. So Here's a visual of what I'm talking about. See how the most of the values cluster around the center, but then there's one over here, and then there's one over here. To see if these are, in fact, outliers, we need to establish, well, first, what's the IQR? And then we have to establish a boundary. And a boundary would be on the high end and on the low end. And I like to think of it as a fence. Anything beyond the fence is an outlier. Anything within this fence is okay. It's not an outlier. I'm going to show you the steps in order to find that boundary. So this again is on your yellow sheet. There are 4 steps. So here are the steps, and then we're going to practice. First, you have to find the IQR. So you learned that in the last video. We're going to have to use that in order to help us find the outliers. Then you have to multiply whatever the IQR is by 1.5. That number, whatever that is, once you multiply that product, you're going to have to do 2 things with it. You have to subtract that number from Q1 and add the number to Q3. Now this might be a little complicated. We're going to take it step by step, and we're going to show you with an example in a minute. Any data values that are beyond those numbers, either less than or greater than, those are the outliers. That's the boundary when you add and subtract from Q1 and Q3. So fill in the word beyond. And we're just going to use this blank paper, so just fill in the example as we do it together. So our data numbers for this example are going to be 555. So at the top, just write example for outliers. So we're going to have our data set at the top. There are 3 5s. I'm already going to put these in order for you to make it easier. A 6, 3 7s, and an 11. So most of the numbers seem to cluster around 5, 6, and 7. Now we have that odd guy, 11. We have to find out if he is an outlier. Let's call him 8. In order to do that, we have to find the IQR. So step 1 is to find the IQR. Now, quick review from last time. In order to find the IQR, we have to find the median first. So we're going to eliminate numbers. There's 3 on this side, 3 on this side. So the middle value actually is halfway in between 6 and 7. So that's 6.5. Now we have to use 6, 5, 5, and 5 to find the middle of those 4. So if I'm going to cross or check them off, we have 2 numbers in the center on the low end, and they're both the same, which means Q1 is 5. So that's what we need for the QR, the IQR. This was Q2, and now we have to go over to the upper half and find the middle value here. We have a 7 and 11, and that leaves us with 2 7s here, meaning Q3 is a 7. In order to find the IQR, we're going to take our 7, which is our Q3, subtract it from 5, and our IQR is 2. So that's step 1. We need this number because now we're going to take 2, and for step 2, we're going to multiply 2 by 1.5, which is 3. Now this helps us get the fence, the boundary. So for step number 3, we're going to take our Q1, our 5, and we're going to subtract 3 from 5, and we get 2. And then we're going to take our Q3, our 7, and we're going to add 3 to it. these numbers, 2 and 10, are our boundary, is our fence. So anything less than 2 is an outlier, and anything greater than 10 is also an outlier, which proves to us that yes, 11 is outside, it's beyond that boundary, so 11 is an outlier. Now why, I know you're asking, do we even need to worry about outliers? Well, like I said in the beginning, outliers are troublemakers. They cause trouble, especially for certain landmarks or certain measures of center that we use. So we have to be conscious of whether there's an outlier or not in our data set. So why bother? Data collection is messy. Outliers do exist. You could ask a question, someone could have a really random answer, and that's their answer, and it's not what most of the population said. And they can mess things up. We need to know how outliers can affect our ways of summarizing information. So what I'm going to have you do is turn to page 68 in your notebook, and we're going to write down how do outliers affect the mean, median, mode, and then we're going to flip and talk about range. So that, if you're wondering, is this page right here in your notebook. So I want you to turn to this page. There should be some space over here for us to write in. We're just going to write about whether the outlier affects each one of these. So the main thing that is affected if there is an outlier is the mean. So I want you to write right over here, an outlier can affect the mean. If you're talking about medians, it's okay to use with outliers and find the median even if there is an outlier, because as you cross things out, you get rid of those outliers to find the middle value. So it's okay to use, or fair. So right here I'm going to say it's fair to use, it's okay to use with an outlier. Another way of thinking about it is that outliers don't affect median. It does affect the mean, does not really affect the median. It also does not affect the mode. So by mode, I want you to write on the side, not affected by outliers. So far, outliers affect the mean, not so much median and mode. Usually the mode is going to be the one that's occurring the most, and it won't be that outlier. The last thing I want you to do, after you write those little notes on the side of page 68, is to flip to this page. It's page 70 in my notebook. It's the one that's orange that talked about range. And hopefully you have a little bit of space next to the range. Outliers do affect range, so we're going to write that as well. So outliers affect range. They affect the range because you're taking the highest value and the lowest value and subtracting them. So if you include the outliers, your range is going to be a lot bigger than if you don't. That's why it's important to know that outliers affect mean and range, and they don't really affect median and mode. My last thing for you to try in this video is an example. Basically, you're having ages of candidates in an election, and there's ages 23, 48, 49, 55, 57, 63, and 72. Your job is to find if any of those numbers are outliers. Good luck. I'll see you tomorrow to practice this and measures of variation.